Hello everyone and welcome to STA 2023 Intro to Stats 1. So this is the actual lecture 1 and today we'll introduce some fundamentals in statistics. We'll define mainly four things. What's a parameter, what's a statistic, what's a sample, and what's a population. So instead of starting directly from the uploaded notes, which can be found on Canvas, we'll start with a 5-minute example, which is a story and motivation, because my teaching philosophy is that it's better to avoid bombarding students with a bunch of definitions, and instead it's better to start with an example. And this 5-minute example and story will help you a lot if you understand everything. And after this 5-minute story and motivation, we'll start our we'll continue with the actual notes which are like uploaded on Canvas. So let's start with this 5-minute motivation. So first, imagine that this list contains all 82 different students of our current class, of our STA 2023 class. Each one of them is a different different student. And imagine that we counted the GPA of the enrolled students in the current STA 23 class. In other words, we counted the GPA of the 82 different students. Each of these 8 dots represent the GPA of one of the 82 students. So in total we have 82 dots, right? This is the lowest GPA of one of the 82 students, and this is the highest GPA, right? To clarify even more, this dark green dot represents a student who had a GPA of 3.9, with the maximum GPA being possible being is 4, right? And this dark green dot, this one, represents a student who had a GPA of 1.7. And this one represents a GPA of student who had a GPA of 3.2. So this dot. So we did this same thing for all 82 students, right? That's why we have 82 different dots, but you can't like see each one of them because some of them are on the top of the other ones, right? So you should imagine that. So this is a plot, and because this plot represents all students of our class, in other words, all students of our interest, which contains our current STA 2023 class, a statistician would say that it represents a population. But be careful. If we change the content of our interest, for example, if instead of being interested in the GPA of our class, we were interested in the GPA of the entire University of Florida students, then the population of interest would change, right? Because we would be interested in the GPA of all. How many students do we have at UF? 52,000 something. So we will be interested in the GPA of 52,000 students, right? So in that case, the population would change to something else, to the entire population of UF, right? So this population changes if we change the content of the question. But in our example, this plot represents the population. And now we'll calculate numerical summaries of this population. Actually, just a numerical summary, the mean. So numerical summaries are mean, standard deviation, and more, etc. And we'll see more in the next lectures. Numerical summaries of a population of interest are called parameters. This is crucial definition. which means that the mean and the standard deviation are both parameters. And then if we go ahead and calculate the average of these 82 dots, in other words, if we calculate the mean, if you add each one of them and divide by the total, which is 82, you will find that it will be equal to 1.8. This 1.8 number represents the average or the mean of this population. And we call this population because we are interested in the, the 82 students, right? In other words, the population mean, which has, we use this letter, the Greek letter mi or mu, will be equal to 1.8. However, most of the time it's not possible to directly measure and calculate the value of population parameter. So they are usually unknown. Why? You have to ask yourself why. The reason is because usually the population of interest is way a large number. For example, if we change the population of interest to the entire University of Florida students, then the population of interest will contain like 52,000 different dots, which is very expensive task to ask each individual their GPA, right? Or it can be, I don't know, another like large number. So it's not just the 82, which is it's a small number. So it will be a very expensive task. That's why the value of the population parameter is really unknown. So again, we go back, but this time, instead of calculating all 82 different GPAs, we will use another tactic. Instead of calculating all 82 GPAs, instead of having, in other words, 82 different dots, we randomly draw the GPA of some of the students. We asked only 5 students their GPA from the entire population of interest that we are interested in. Even though we are interested in the GPA of all 82 students, we just randomly ask 5 students their population, their GPA. So we have a subset of the population. We have a subset of the 82 students because we ask just 5 randomly selected people their GPA, and we calculate this individual like the 5 different GPAs. This randomly drawn subset of the population, it is called sample. And the size of this sample is equal to 5 because we have 5 different students. Since usually the parameters of the population of interest is unknown because we don't usually go and ask 82 different students their GPA, or we don't go and ask 52,000 different students their GPA. In that case, the usual tactic is to almost always estimate the population parameter like we do over here using a small sample. In our case, the sample is 5 different students of the actual population of interest. And again, numerical summaries, which is mean or standard deviation, more we will see later, of a sample this time. The numerical summaries of a sample are called statistics. Remember previously the numerical summaries of the population, we would call them parameters. This is very crucial to remember. So the mean, or in other words, the average of a sample is called a statistic. So if we go ahead and we calculate the average of these 5 different students' GPAs, so if we add the GPA of this student, this student, this student, this student, this student, and we divide by the total number of the students, which is 5, we'll find that the mean, their average, is equal to 1.7. So the mean over the average of this sample is equal to 1.7. We can call this sample mean, and we use this symbol, which is x bar, to represent the sample mean. So up to this point, we did two different things. So this was our original population, right, of the 82 students, and this is the randomly drawn 5 students out of total population of interest, which is our sample. That's why we have only 5 dots here. So in statistics, we use this sample of the 5 students randomly selected. We use sample statistics to estimate the population parameters, because it's a very hard task to ask each students their GPA, right? And you should remember these letters SS, so sample statistics and the population parameters PP. And one of the main goals in statistics is to quantify how much confidence we have in the population estimates. Specifically, statisticians often calculate p-values and confidence intervals to quantify the confidence in the estimated parameters. This is called, this is a branch of like statistical inference, but we will see more in the next lectures about this. So again, we usually in statistics use this randomly selected 5 students to estimate something about the entire population, which in our case was the 82 students, right? So we sample the GPA, we calculate the GPA of 5 randomly selected students, and we use this to estimate the average GPA of the 82 students, because it's a hard task to ask each one of the 82 students their GPA. Generally speaking, the more sample data we have, the more students we randomly select from the population. So if we had more 10 randomly selected students instead of 5, we would be like more confident. We will have more confidence in the parameter estimates. So the more we sample, the better, the more confident about the result of our sample mean or any other statistic. We'll be more confident. So a summary. Population represents the entire individual of a group that we are interested in collecting a specific information about. So in our example, the population, it was, since we were interested in the GPA of the 82 students, the population was the GPA of the 82 students, right? That represent the group of the 82 students of our class. Then the parameter is the numerical summary of the population. A parameter can be the mean or the average of the GPA or the standard deviation. So both mean and standard deviation are called numerical summaries. Then the sample is a randomly drawn subset of the population. In our case, the sample was the 5 randomly selected students out of the 82, right, of our population. Then the statistic is the numerical summary of a sample. In our case, this was the X bar. So the average of the 5 students drawn, the average of their GPA, it's called a statistic. While the average of uh, the GPA of the 82 students, it's called a parameter. Again, the parameters are usually unknown because it's very hard to calculate the GPA, for example, of each of the 82 students and then calculate their average. And usually the population is way larger number, not just 82. So since it's usually unknown, we use the corresponding statistics to estimate them. So in our case, we used um, the average GPA of the 5 students to estimate the average GPA of the 82 students, right? So this is all. This is what statistic, a huge portion of the statistic that we do. We use a sample to estimate something about the larger population, and then we check. We have to know whether how much confidence we have in our estimation. So this is a summary and the motivation. This is the end of the motivation. And now we'll start our actual notes, which is on Canvas. So this is the actual lecture notes that you have in Canvas, and we'll start right now. So what is statistics? The art of the book, that our textbook says that we have there's some procedures that we do. It's like designing studies, uh, analyzing the data, and translating data into knowledge, like actually we did. So, and who uses statistics? Like everyone. We use it in marketing, in medical studies, in if drinking alcohol in moderation is good or bad for your blood pressure. So we predict things based on some other variables. And in sports, who is the best baseball pitcher, and etc. And why use statistics? Statistical methods. So actually, the statistical methods that we undergo when we are doing a study is, first, we have to design. Actually, at this moment, I would pause the video and check after reading the statistical methods, which is the design, which is like plan how to obtain the data. It can be experiment or survey. We have to decide which one is, and then collect the data. Then the description, which summarize the data with graphs. Graphs can be like histograms, box plots, dot plots, and also the numerical summaries. It's in the description category in the concept. As I said, numerical summaries, if you remember, it's like the mean and standard deviation, the mode, etc. Then, after that point, the next thing we do is doing the inference, the third thing. Inference is like using the data from a random and representative sample to draw a conclusion about the concepts and how sample summarizes some sample summaries like behave, which is what we actually did in the first 5 minutes. And this allows us to attach a measure of how reliable and how confident we are uh, to our inference conclusion. So after that, at this moment, I will probably pause the video and go back in these notes and try to like find where we did each one of these, which I will actually tell you. The design part is like the asking the question. This is how we collect the data. We we wanted to know what's the average GPA of the students, right? And so we ask from each individual student their GPA. This is the design phase. Then the description. Let's say this graph. Let's say it's a graph. is in the phase of description, and then the calculation of the mean of the sample is again in the description category, right? Because we calculate the numerical summary, which is the mean. Then it's the inference phase, which is we use the data from a random sample. The sample is what's this, right? That we sampled. To draw conclusions about the population of interest, which were like the 82 students. And in other words, conclusion, which means this phase we try to estimate the population of the parameters, right? This is the inference phase, and the last thing is that, yeah, these are the first like 4 concepts, and then, as I said, generally speaking, we try to like examine how confident we are if the population estimates are correct or not, based on by calculated because we sampled specific students. So we have to examine it, and we do that with statistical inference, which is the other concepts, and we use confidence intervals and significance tests. So we use p-values here to, let's say, so the confidence interval is how much uncertainty gives us how much uncertainty there is with a particular statistic, like the one that we calculated. So we calculate the interval, and the significant test is like someone is making a claim that the average GPA of the students of our class is like equals to, I don't know, 3.5. So this is a claim which is usually called the null hypothesis. And there is an alternative one which is called alternative HA, and we use the p-value, which is a probability based on the sample data, to decide whether we will accept this claim or reject it based on the value. So we'll do this in chapter 8-9. We'll also learn in this class how to make like confidence intervals and significant test for a population average. Which means what is the true average GPA of all students at your school? True average in other words, it means population, the average of the population. So the mean of the population, if we in our example we were able to calculate it right directly because we had very few students. So it was called the 1.8. If you go, it's also called true average GPA. So what is the true average GPA of all students at your school? A population proportion, which is like what proportion of students at your school who drink alcohol. That also will do confidence interval, the significant test to compare two population average to compare the salaries for male and females, like which are two different populations, and to compare two population proportions. So to compare the proportion of Democrats and Republicans who believe in gun control. And we'll learn how to compare two groups in chapter 10, and then the rest of the big sense statistical inference for comparing like several groups. So let's start here. So right now, sample versus population, which we already said what's the meaning of these two. So first is the design phase, right? Like we did previously. Right. This time we are asking what is the average height of people in US. Height. So you have to know. So population of interest this time is the all people in the US, right? But let's go like this, like that. So people, animal, and objects which have like a constant value, like the students in the previous example, the 82 students or the 5 actual students, they are called subjects. And the variables are the characteristics that we measure on each subject, and we call them variables because they can take different values for each individual. So in this question, height is the variable, right? Because it takes different values for each person in the US, and each people is like a subject. In the previous example, you could pause the video and think what was the subject and the variable. So pause and think about these two. The answer is the subjects were the students, and the variables were the GPAs of each student. Then population are all subject of interest, which is said. Sample is the subjects from whom we have data. Again, in the previous example, it was the 5 students, right? And the population they were the 82 students. In other words, all the students were interested. So in this example, as I said this. So this time, as you can see, the population is way larger. So we can't do anything. We can't like calculate the parameters directly. It's impossible. Like we have to ask every person in the US, or if we do it, it's like with census. So we have to use the sample to estimate this, right? So for example, we are randomly asking 50 people on the street something, whatever their height, then random sampling. It's like it means that each member of our population has the same chance of being included in the sample. Random samples tend to be representative of the population, so we can draw a better conclusion about it. So our estimates, will be more confident in our estimates, but we've done using the sample about the population. If we've done random sampling, then parameters, as I said, numerical summary of the population. Statistics are numerical summaries of the sample, and numerical summaries, as I said, is the mean and standard deviation, and some more that we will see, like the mode and the median. That does not. But right now, let's go and see this example. Also, the sample statistic, as I said this. So this example says internet sites report that about 13% of Americans are left-handed. Is this true for students at your university? So this is a design question, right? During a statistic exam, The instructor walks around the room and counts 15 left-handed students out of 98 students in the class. So we have to identify the following. First of all, what's the variable in this question was, which means what are we interested in to find? What are we like asking? What are we trying to find? So the variable in our example previously, or here is like the height of each student, of each people, every people in the US. Or here you have to think what's the variable. As you can see, we have this information. So the answer is like whether the person is like left-handed or right-handed. So the dominant hand, left or right. So it's a variable because it varies from person to person, right? Like the GPA and like the height. Then the population, I'm using these colors because I use these colors in the main introduction motivation. I feel like it's easier to see remember the stuff if you have the color. So the population, we have to think what's the population, right? So we are trying to find who are we interested in. We are not interested in this thing, right? Internstats reports about 13% of Americans. We don't care about all Americans, but as you can see, the next sentence is like, is this true for students at your university? So we are interested at students in our university. All students at your university. Population means all subjects of interest. So we are interested in all students at our university. So not Americans. I mean like this is like irrelevant like information. Then where is the sample? So from all like students of our university in our class during a statistics exam, which was in our class, the instructor like asked 98 students something, right? Which means this is the sample, a smaller subset of all people in university, which is a subset of population, which means like the sample is equal to 98 students which are in our class. Then the parameter, what's the value actually of the parameter? We don't know it, right? We just know this information, and someone can say like assume that this is this is true for all students at our university, which is wrong because it just says about 13% of all Americans, but we are interested in truth in the students of our university. So actually, parameter is like a numerical summary, right? In this example, a numerical summary isn't the mean, right? It's not average. We are not trying to find any mean. Instead, as you can see, we are trying to find a proportion, which is like, as you can see, the percent is a proportion of the left-handed students. So population is the population proportion. Proportions are numerical summary of all students at university who are left-handed, right? So this is in the previous example, the proportions in numerical summary in our example, which was the mean previously, or the standard deviation, but right now we are trying to calculate this parameter, which is unknown because we don't have any information about all students of our university. As you can see, the population this time is like all students at our university right here. So we want to estimate the numerical summary of the population. So the population changes at the interest or the population that we're interested in changes among problem, right? Because previously we were interested just in the population of our class. Right now we're interested in the population of all the university, which is it's different. It changed. So it's upon us how we define the question and we are interested in. Then the statistic. Again, the numerical summary that we are interested in is the proportion of students who are left-handed. So we use in statistic to calculate, we use the sample, right? We use the sample, and proportion, it's given by the number of here the left-handed divided with the denominator is the total number of students. So this is what we are interested in. We are interested in this because of the question, right? And this is like the 98 contains the 15 left-handed plus the right-handed, right? So this is the equation of proportion actually. So 15% of sample is left-handed. So the next thing is, was a random sampling, like we sampled the 98 students randomly from the population, which is the whole university students? The answer is like no, because all students in the same class, in our class, in statistics class, may have something in common. Major, like year, they are in the same year, right? Because they are taking the same exam. And which is random sampling. Because we didn't like sample from the entire like students of university randomly. Or they are all from our major, from our year, and most likely they might have even the same interests. So this is a very bad way to sample actually. So because we want to use random sample, so that's all people have which means that all people, every individual of the population have the same probability to be chosen. And the reason that we want random sampling is because if we estimate the statistic, if we estimate something about the population and numerical something about the parameter about population, the method that we sampled from the population is very important. Whether we will be confident in our estimation. This is actually the end of the class.